me.
We're not going to do jump conditional if condition is met. That's just way too much. But CMP, I already showed you some CMP is performed by subtracting the second from the first and setting the status flags. This sets the flags of if they're equal, if they're greater than, if they're less than, and a bunch of other flags as well. And I actually already showcased this with our code, so let's move on. We are not going to run the test instruction. And I think we already showed this. Why are we showing this? Oh, we did the and. Did we already do that? I thought we did this one.
We did and, but I don't think it was in that specific example that they were trying to.
Oh yeah, we did an and right here. I thought so. All right, they're just showing you how and works. Here it is. And we talked about that already, as well as comparing and to 0. Let's move on. Bitwise logic. All right, so these slides need to be rearranged a bit for next time. We talked about and. By the way, you do have or, and you have XOR. So you have all of those. And you have not. Now this is one's complement negation, which means that it changes all your zeros to ones and all your ones to zeros. Great. All right, finally a loop. Good, we got it. We got time for this. 08 loop.
I'm going to guess that it's going to keep jumping until...
All right, up on top, we have our format, what I is equal to. We set up the stack. We're going to push ECX, which we're going to say is our I. By pushing this, we're allocating space on the stack for us to use later. It's not actually pushing an important value, it's just allocating the space on the stack. Because right here, we move 0 into that stack space. So this EBP minus 4 is going to be our I. We jump to the loop in. This is going to be kind of confusing while we're doing that. But the point of this is we want to jump to the end, which immediately tests our loop. If you recall a for loop, you set the value and then you do the test. When you do looping, it's easier to have the test done at the end. So we're just going to jump to loop end, which is down here. We're going to compare I, which is EBP minus 4, compared to 10, which is A in hex. And jump if greater than or equal to, aka if I is equal to 10 or is greater than, we need to exit. Because remember, we're testing if I is less than 10, so the opposite of that is if it's greater than or equal. We jump to exit. But if we're not jumping to exit, then we're going to go ahead and get I from memory, put it in ECX, push it on here because we're about ready to call printf. Let me scroll down a bit. ECX, print the format, call printf, decrement the stack, and then jump back to the start of the loop. Well, the start of the loop, what does it do? If you recall with that for loop, you have that third item over there, the I++. So we grab I, we add 1 to it, and then we store it back in. Grab I from memory, add 1 to it, store it back out to memory. Then we go to loop in where we test and compare, and then jump if necessary. Otherwise, we go ahead and call printf. Then, at some point, I's will be 10 or greater than, so we jump to exit, which goes down here. We pop ECX to get rid of the stack. We zero out EAX, just showing you there's another way to make EAX 0. It could have been move EAX, 0, or you can XOR it. And then clean up the stack and return. All right, let's go ahead and run this. Hey, well, that was fast.
Yay.
0 through 9.
Okay.
All right, how are we doing?
So basically, it's going to keep doing it keeps basically using jumps, and it's going to keep jumping back and forth. Like, it's going to go through the loop, but only jumps.
Important notes. There are no if statements, there are no while loops, there's no for loops inside of assembly. You only have jumps and conditionals.
So
All your programs always go down to jumps and conditionals.
So
All of them.
Okay, I think I understand. So it keeps going down, and it goes, okay, it hasn't met the condition, so it jumps back up to start.
You got it,
and
yeah.
It keeps jumping back into start until the comparison is met.
Right.
And then it jumps to exit.
Everyone got how for loop
Right.
works? Sam, did you know that's how for loop works? What?
So that's how it's very easy.
All right, any other questions about a loop?
This is how you accidentally get yourself stuck in it.
All right, cool. So let me go ahead and stop this for now.